Welcome to the historic Livery Theatre here in beautiful downtown Goderich. We're talking all about salt today. My name's Rob Bundy. I've got my guys up here, my technicians. We got Adam and Nick. They're pushing the buttons, keeping us on time, twisting the knobs and all that kind of thing. We're here to talk about what's below our feet, what makes Goderich what it is. Not only is it a great place to live, but a great place to work. And one of those great places is the salt mine that's been here for a long time. So we're joined now by Engineering and Capital Manager. He's right over here. His name's Robert McVeigh. Robert, have you got a few things to tell us about salt here in Goderich?
Absolutely, Rob.
Excellent. Thank you very much.
You guys are able to hear me good? Perfect. So as Rob mentioned, my name's Robert McVeigh. I'm the Engineering and Capital Manager at Compass Minerals Goderich Mine here in town. I've been with Compass about 5 years, and I will touch on a bit of my background and what makes me feel qualified to be here in front of you folks talking about the mine. So I grew up in a tiny mining town called New Waterford, Nova Scotia, on beautiful Cape Breton Island. I did take an engineering degree in university with a specialty in mining engineering. So I graduated from Dalhousie University and spent about 7 years in Sussex, New Brunswick, working at a potash mine. So it's interesting, potash is also a salt, not the one we're here talking about today, but it's a potassium product. So KCl instead of NaCl, which is our normal road salt, and potash is actually used as a fertilizer. So my entire career, I've been fortunate enough to work in different types of salt, and that's really what led me here to Goderich quite a while later. So I spent about 7 years in an engineering role in New Brunswick before that mine was shuttered, and I spent about 2 years after that in Pugwash, Nova Scotia, at an underground salt mine, which would be a competitor of Compass Minerals. In 2019, I got a call from a recruiter in the area that was curious if I was interested in coming to Goderich to work at the mine. Throughout my whole career, I had heard great things about Goderich and how beautiful the town was, how great the mine was, and on coming here, I found all that stuff to be true. So I'm pretty passionate about salt. You'll probably realize that, and I like it here, love it here, and have been fortunate enough to meet a great girl from Huron County, and we've got an 18-month-old daughter now. So very happy in the area and very happy to be working here at Compass Minerals. So I'll go through a bit about the history of the mine. I'll have a couple of videos within the presentation, and I'll try to wrap it up in about 40 minutes, at which point I'll open it up to the floor for any questions you guys may have. So starting with the first video, this will touch on a bit of the history of the mine itself.
Welcome to the largest underground salt mine in the entire world, located in Goderich, Ontario. Miners travel over 1,800 feet below the ground to start their workday. This is the same distance as the height of the CN Tower in Toronto, Canada. But how was a salt mine discovered underneath a lake? Well, in this case, by accident. In 1866, local mill owner Samuel Platt teamed up with chief driller Peter McEwen in hopes of drilling into the ground and discovering oil. Instead, after 102 days of drilling, the two discovered 40 feet of salt rock. A new industry in the town of Goderich was born. So how exactly does salt go from here to here? Salt begins its life underground in the form of rocks that cover the walls, ceilings, and floors of the mine tunnels. Mine engineers start by utilizing the latest technologies to provide plans for the safe extraction of salt on a seemingly endless network of roadways. After all, the priority of the salt mine is everyone's safety, while meeting production demand, maintaining all active openings, and supporting the equipment. The ground control team oversees all scaling activities to mitigate any dangers. Areas requiring scaling will use large scaling machines, hand tools, and even explosives to alleviate any risks. Then, following the engineered plans, the miners begin the cutting process of the walls and ceilings. This is done by a machine called the continuous miner, a remote-controlled 50-foot-long machine that uses metal teeth attached to the cutting drum to cut through the layers of rock and salt. The width and height of the walls depends on where the mining is happening. But typically, these walls are cut at a height of just over 14 feet in increments of 4 passes. That means the complete height of an underground pathway is over 55 feet tall, enabling the miners to move and use all sorts of giant, heavy machinery as the metal teeth cut the salt rock. The gathering head, underneath the cutter drum, carries the salt chunks onto the continuous miner's conveyor chain, where it is dumped into a large haulage truck or a flexible conveyor train. When the haulage truck is full, this vehicle hauls 40 tons of rock salt to a separate location called the stockout. Loaders at the stockout will scoop the salt rock and place it into the east or west conveyor belts. Remember, this is the largest underground salt mine in the world. Its expansion under the lake is farther than the length of its hometown. Once on the conveyors, the salt rock is crushed up into small pieces and travels toward the underground milling operation. The underground mill is a screening process near the front of the mine. It uses mechanical and optical sorting tables to separate the pieces of high-grade salt to produce two products, chemical and highway salt. They are deposited along two different belt lines and into their own stockpiles. These stockpiles are then pushed into trench chutes in the ground, placed onto a conveyor, and travel up to the surface inside of 30-ton skips. The skips dump onto conveyor cars that carry the salt to separate storage domes above the ground, where finally, the salt is loaded onto transport trucks, trains, or boats, and delivered around the Great Lakes to highway salt storage piles and some evaporator plants for salt bagging, testing, and packaging. In Goderich, the evaporator plant processes evaporated salt by boiling saturated brine. This brine is mined from salt deposits in 3 active brine wells, which are down in the river flats by the Maitland River. At a staggering 400 gallons a minute, saturated brine is sent back from those wells and into the evaporation process. There are 5 phases of mechanical evaporation: boiling, vapor, steam, drying, and finally the salt crystals that you see on your dinner table. Once the salt crystals are made, chemical testing and product research are conducted on site at the Evaporator laboratory. One example of a test that they do every single day is called the purity test. It's a big responsibility to know that the salt crystals are meeting their purity standards. That way, the food and products that people eat and use are being produced at the best and safest quality that they can be. Being able to test the salt crystals on site enables the staff to have rapid results and respond quickly to the outcome. Some examples of these salt products include agricultural products, food-grade products, pool salt, and even cosmetics. So the next time that you see the salt truck on the road, or refill your water softener tank at home, or grab your groceries at the store, remember where that tiny mineral came from.
So that's a bit of the process. I will get a bit more into the technical details of what we do underground as the presentation goes on. But to start with, I did want to touch on Compass Minerals itself and the company and how big we are, I guess, where we operate in the world. We do have 3 underground mines within our fleet, as well as many evaporation plants and packaging plants throughout North America, as well as 1 underground mine within the United Kingdom in Winsford. Goderich is the largest underground salt mine in the world, and we're obviously the largest of Compass's fleet by probably a factor of 3 or 4. Here in Goderich, we ship a lot of product to the evaporation plant in town for packaging as well as Chicago, Buffalo, all throughout the Great Lakes. What really allows Goderich to be such a big producer is their position on Lake Huron. We can access all the big Midwestern U.S. cities, as well as Toronto, Montreal, and we're fortunate enough to have a very deep water port. Salt is what you'd call a bulk commodity, so it becomes very expensive to ship salt any great distance over land by train or truck. So we're lucky that about 90% of our product goes out on vessels. Just a map showing the position of the operations. You can see quite a bit located around the Great Lakes themselves, but our sister mine in North America is located in Louisiana, down to the south, and services that part of the world with canals up the Mississippi River, and we really service the Great Lakes area, as I mentioned, and the large cities like Toronto, Cleveland, Chicago, so on and so forth. So a few photos of the mining operation itself through the years. We were established in the late 1950s. The first shafts were sunk, and by shafts I mean the vertical holes that go down within the mine itself. There are 3 shafts at the Goderich mine site, so we're fortunate to have that. The 3rd shaft was sunk in about the 1970s, so over the years the production was expanded quite a bit as the years went on. The mine started out fairly small, and now we can make about 8 million tons per year of road salt as a nameplate capacity. We obviously swing that production up or down as needed to meet the market demand because we are largely a weather-based business. This past winter, unfortunately, it became very mild, and we had to slow our production down to match demand, and fingers crossed we'll have a very strong winter coming and be able to distribute a lot of salt around the lakes. A couple key notes in that photo. We did conduct a fairly big relining process of our 3 shafts in the 2016 to 2019 period, where about $200+ million was spent at the mine site to really secure things for the next 50 years of mining and into the future. In the early 2010s, unfortunately, Goderich itself, as many of you would know, and the mine site were struck by a fairly significant tornado, which knocked a few of our buildings down and very unfortunately killed somebody at the mine site while he was in the ship loader that happened to tip over due to the ferocity of the storm itself. The last picture, you can see quite a nice looking site, I would say, all blue buildings reconstructed after the relining and the tornado itself. And if you drive down to the peninsula now, you'll see a very similar looking site, which you see right there. So some of the geologic history, how the salt was actually deposited. The rocks we mine are about 430 million years old. So the Silurian age is the geologic period at which they were formed. And here in southern Ontario, the rocks are very much as they were deposited. So incredibly flat lying, they dip very gently, and by dip I mean tilt, out to the southwest under the lake. So as we go out under the lake, the salt is getting slightly deeper the further and further we go out. The salt itself actually extends all the way across Lake Huron to the Michigan Peninsula, so it's very extensive. We're about 6 kilometers out under the lake at this point, and we have about 80 years of published mining reserves remaining here at Goderich Mine. That's not the end of the salt deposit, that's just what our existing lease would cover, with the potential to the north or south or further to the west as well. The salt itself is a sedimentary rock, it's called. So there's 3 different types of rocks in the world: igneous, metamorphic, and sedimentary. They all really begin as sedimentary, which is when sediment is laid down and buried by other rocks and compacted to the point that it becomes lithified or turned into rock itself. So salt is an evaporite mineral, they're called, similar to potash, gypsum, a few others. But it forms from the evaporation of seawater. So at some point, the entire area we're on was a great big salty basin that at some point became separated off from the ocean itself, and evaporation led to the water disappearing over the years and ended up with our about 100-foot thick seam of salt behind. So it's quite interesting if you were to look into how much salt is in seawater and how much water itself would have had to evaporate over the millions and millions of years to leave behind our 100 feet of salt. So the underground mining, you saw a bit of this in the video, but we are about as deep as the CN Tower is tall, and the mine extends entirely out under Lake Huron. We don't do any mining under the shoreline or under the town itself. Everything is out under the lake, and everyone's day starts with about a 20-minute drive out to the working faces because all the salt in the near shaft area has been mined out. We do mine about 60 feet of that 100-foot seam. So if you look at that picture, it's incredibly shocking how much of a volume we've opened up underground. Each one of those tunnels you see on there is about 60 feet wide by 60 feet tall, and that's 60-plus years of mining at this point that have led to that amount of excavation. A lot of people will ask, do you feel comfortable under the lake, for example? Because of the water, I'm sure you all would realize that water is not something you want in an underground salt mine. You put salt in water, it disappears, obviously. So if you happen to develop a leak into the mine, the leak will generally start as a drip, and over time that drip gets worse and worse as it washes the salt away and opens up a bigger and bigger cavern, and the rate of inflow actually increases. So I mentioned having worked in New Brunswick at an underground salt and potash mine. I don't work there anymore because of a leak that developed. And exactly that happened. We installed a bolt into the ceiling, a drip began to develop, and that ended up being an 1,800 gallon a minute inflow into the mine. And it's not just normal water that you can dispose of. It ends up being a saturated salt brine. so you can't put it in a nearby river or deposit easily. In New Brunswick, we had to build a multi-million-dollar pipeline to take that saturated brine from Sussex to the Bay of Fundy and discharge it into the Bay of Fundy. Here in Goderich, knock on wood, we're very fortunate that we have no leaks into the mine. There's no groundwater present. About 900 feet down, the rocks tighten up and dry up. Above that, they're very damp and wet aquifers, but we have a very thick beam above our mining horizon of dry rocks that prevents any of the mining infrastructure or mining openings from extending up into those water-bearing strata. So what's the salt used for? I think most of you have a pretty good idea, but road salt is our primary product. About the vast majority of what we produce ends up distributed on the roads around the Midwest, around this part of the world, but we do make something, as you saw in the video, called chemical salt. About 9% of our production is chemical salt, a very high purity product that we send to various chemical plants around the world where they actually dissolve that to make a brine and use that brine to make products like polyvinyl chloride and detergents and a variety of household items that you wouldn't realize actually have salt in them. So how the salt actually moves throughout the mine, from the underground storage locations, we ship to a surface storage location. So the great big buildings you see down at the mine are 5-dome, as we call it, the big white structure. That holds about 2 days production for us. So it looks like a massive building, but if we don't have vessels coming into the site or trucks to take our salt off site, for example, in November when it's quite stormy, this can be a problem. The buildings will fill up and almost bring the mine to a halt while we run out of space to put that salt underground. After it leaves our site, we ship it to distribution depots around the Great Lakes, where we then ship to our customers later in the season. So most of our customers that have very small domes themselves that might only hold a couple hundred tons, and we produce, between, depending on the year, between 15 and 25,000 tons per day. So we have to have a massive distribution network around the Great Lakes to fill them up during the summer season and then distribute all that over a very short period in the wintertime. The underground mining process until about 2014 was entirely what we'd call drill and blast mining. So we would do a top cut, we'd call it, a development cut with tiny equipment, for example, 11-foot tall equipment, and that's what you see in the bottom left photo there, a development cut. So we would use a great big chainsaw device called an under and over cutter to cut a 6-inch slot in the roof and the floor. And then a drill would come in and drill a series of holes in the face that would then be loaded with explosives and set off. The 6-inch cut at the roof and the floor allowed for room for those explosives to go off and expand and break properly. If we didn't have those cuts, the rock would freeze in place and not fracture as it's supposed to. So after that development cut is done, we would go in and scoop the salt out, install what we call ground support into the roof, so rock bolts 7 foot 6 feet long to support the overlying rocks. And then we would do what's called bench mining. So a downhole drill would come into the opening, drill holes within the floor that we'd then pour explosives into, and then blast about 45 to 50 feet of salt at once, which is what you see in the top left photo. So a great big haul truck that you'd normally see on surface, a Caterpillar 775, looks fairly tiny in our opening underground, which is very out of the ordinary for mines. That was a very cheap and efficient way to blast the salt, very economical, but it had some downsides, as you can imagine. As we're 6 kilometers out under the lake, we have to provide fresh air all the way to those headings and then carry it back to the shafts to exhaust up one of those shafts. So when you're blasting, the explosives obviously use or set off a lot of NO2 and CO, or nitrogen dioxide and carbon monoxide, enters the airstream, and we have to carry that out of the mine and ventilate. And then all those trucks are generally greater than 800 horsepower, a lot of diesel being used underground to move the salt around and haul it to our various crushers, which again kind of contaminated that airstream. Every year in Ontario, as you would expect, the limits for NO2 and CO exposure, as well as diesel particulate matter, get more and more stringent. So around 2014, we began a process to switch to what's called continuous mining, or using electric mining machines rather than drill blast and the explosives and haul trucks that go with that contaminating the air. So at this point, we're actually entirely continuous mining. Very rarely will we do any blasting, and the air is, I would say, cleaner than downtown London when you're actually down in the mine. You don't notice that soot in the air, the soot on the walls, any blue haze that we would have had in previous years. Here are some photos of the continuous miners. The video would have showed this a bit better, where you can actually see the miners cut. Some of these photos, it's tough to see what the unit actually is because it's a very different looking machine. It has a cutter drum on the head of it that's about 13.5 feet wide, cuts up and down, and actually grinds the salt off the face. The salt travels through the center of the machine on a chain conveyor and dumps onto a mobile conveyor belt behind it. So ideally, we don't ever have to pick the salt up with a truck or a front-end loader. It goes from the miner on about 8 kilometers of conveyor belt all the way back to the shaft area where the buckets and the shafts bring it to surface. Some of what we do in the underground mill. So we don't actually sell 100% of what we produce. The salt itself has some discontinuities within it, layers of clay within it, that we mill out and separate. So the underground mill is based on a very similar process to, say, a gravel plant, where it's all crushing and screening. So the salt crushes fairly easily and passes through the screens, where the rock will be retained on the screens because it doesn't break as easily. And we grind that again to liberate more salt, and then what remains after that we use as a waste product within the mine. So less than 10% of what we produce stays underground and ends up back in the openings that we've mined out as a waste product, as backfill to the underground openings. The chemical sorters that are shown on the bottom right are some very impressive technology. They actually are fed a bed of salt that flows across them about this kind of width. There's a camera that's aimed at that chemical sorter that actually identifies the black spots within it. As the salt passes over the edge of the sorter, there's a series of compressed air nozzles. So the computer will see the black salt and tell the machine which nozzle to activate to push that piece of black salt onto a different conveyor belt and reduce the amount of rock that ends up in the final product. So that's how we make our high purity chemical salt that'll be greater than 99% NaCl. Still not as pure as what's produced at the plant, so we don't make any food-grade salt. There's always a chance that there will be remnants of hydraulic oil or back in the day explosives within our product. So all the food-grade salt you would buy at a store is generally evaporated from an underground well and ends up pretty much 99.9% pure NaCl. On surface, as I mentioned, that's the interior of our big white building that you see, 5-dome. There are a series of tunnels underneath that building, and grizzlies they're called, so chutes in the floor with grates on top of them that the salt is fed down into and ends up on a conveyor belt to feed our ship loading system or our truck loading system on the site. The building can hold about 60,000 tons of product, which, as I mentioned, is a bit over 2 days production for us in a very big year. We also load trucks. Generally speaking, it's much larger in the winter months, so January, February, as you can imagine, shipping around this area up to Toronto, Montreal, and so on. It's not economical, as I touched on, to ship with trucks much further than that. We do ship a bit of material by train, but again, it's not economical when compared to a vessel. Most of our vessels hold 25,000 tons of salt, and we can load one in 12 hours. Where the train cars, we can load about 10 in a shift, for example, and they hold 100 tons each. So it's not as economical for us to load out on a train. Some of the people underground, our people are our greatest asset, and I threw this slide in to really show some of them and some of the activities that take place underground. I did pick this slide because I ended up in probably most of those pictures as a result of just being there at the time. And it is a good reminder, actually. You can see a lot of us wearing face masks in that because most of these were taken during the COVID times when things were a bit different at the mine. The top left is an underground crew posing for a photo, one of our production crews down in the mine. Normally, we'd operate 4 crews in the mine for 24/7 operation. Each crew would have about 20 people on it, and the shift schedule would rotate over a 28-day period with about 7 days off as the big advantage for the guys underground. So they enjoyed that 7-day stretch of days off, but unfortunately, you do have another tough 3 weeks to end up getting that 7 days off. To the middle picture on the top, that's an underground diamond drill. So we do conduct exploration drilling in front of the faces. We want to know what's in front of us for salt in case there's any geologic anomalies or changes in the salt bed. We're in an area called the Pinnacle Reef Belt of the Michigan Basin. The Michigan Basin is the salt basin that we mine, and Pinnacle Reefs are a result of a reef many, many million years ago when the salt was being formed, but they're very bad for our production. The reef itself is a harder mineral, a harder rock that our machines can't cut through. So we approach these rocks and end up being stopped and having to change our plans very quickly. So in order to avoid that going forward, we bring a diamond drill into site. We drill about 3,000 feet in front of the miner to make sure that we can look at the core itself and see that there's no rock features in advance of where we want to mine. Certainly, we are a great sponsor of the community. A mine like Goderich employing up to 500 people at a time. We have to be the #1 sponsor in the area. We want to be visible on all the community events, and we strive to do so. Myself, I'm part of the donations committee at the mine, so we try to distribute the money to really the best organizations we can imagine, and try to help out at some of the community organizations around here, like Huron Hospice, I think you see in the top center. The Salt Festival, obviously, this year we'd be a great sponsor of, and it would look pretty bad if we weren't, to be honest. And the bottom right, I think, is an annual donation we do. So at Christmas time, we have a lasagna fundraiser in the mine. That was actually something started by the gentleman who was killed during the tornado, Norm LaBerge, and we've continued with it year after year. Every year has been bigger than previous. So we raise tens of thousands of dollars every year that goes to the Children's Christmas Bureau in this area to donate amongst the children in the area. And I had to go back because the center picture on the bottom is me and that wife I mentioned and our beautiful 18-month-old daughter in the center there. So in summary, some of the items about Goderich Mine. We are the largest underground salt mine in the world, by far, I would say, quite a bit more, probably double the closest competitor. Family and community focused, as I just touched on. We have an excellent safety and production record. Safety is #1 in the mining industry. This is not my grandfather's mining industry anymore. Things have really changed in the last even 10 years, I would say, since I started mining. But safety is paramount. Nothing's more important at the operation. Prime location, as I touched on, the Port of Goderich is actually very helpful as well, and we're a part of the Port of Goderich. But in order to bring those big 25,000-ton vessels in, we have to have a deep water harbor to do so. The previous mine I was at in Nova Scotia, Pugwash, we could only bring in about a 5,000-ton vessel at a time, so it really limits how much production you can do out of the site. And loadout capacity to fill trucks, trains, 2,500 tons an hour to boats, as I touched on. 60,000 tons of storage on surface. And really one of the biggest things is the people in the area that we have working for us and the access to the Great Lakes as well as the extensiveness of the salt body. So I touched on it goes all the way to Lake Huron. It's very much as it was deposited, very flat, easy to follow, where some of the mines I've been at have been contorted by geologic movement over the years, and you might be drifting along and hit rock with your miner and have to change direction. So we're lucky to have a very good deposit to be mining. I will play another video at the end. This one actually almost gives me goosebumps. It makes me quite proud of the operation, but it's much more people-focused than the last one, and it'll show a bit more work under.
The Goderich salt mine is as deep or as far down as the CN Tower is tall, and it goes out approximately 5 kilometers, and it is growing.
Typical day would be starting off with the coffee naturally, coming in, doing a crossover talk with the midnight crew, seeing what happened on the events of the night.
So I look after the overhauls on the continuous miners. So you can see the one behind us here. This is CM1, it's our oldest miner here. I think it's been here about 8 years. It's just in for an overhaul. We do overhauls based on tonnage. Usually it takes about a few weeks to do one of these overhauls.
Well, it's the miner is a pretty big machine. It's a 50-foot machine. It has a crusher wheel, which is the continuous miner part. So then it's full of bits, which is what I'm doing right now, is changing bits. It's 50 feet long, as I said before. It has a gathering head underneath the wheel, and it gathers the muck as it cuts it and comes out on the conveyor belt or conveyor chain, which goes on to the belt, which is the FCT. This is the remote that I use to run the miner. It's very much like the joystick for your PlayStation or Xbox that you got at home. It's a little bit less, where you'll have 2 joysticks. I've got all this in one panel.
This is the Terex bolter. It's a high reach bolter. We're putting in 18-foot bolts today in the back to help hold the back up. We put bolts in the ceiling to prevent the back from caving in, because over time the back likes to settle, to keep everyone safe.
They cut the salt, send it down the belt line into the mill processes it and sends it out to highway side, highway C4, that's our highway salt or road salt, and then the chem C4, that's our chemical salt. So after it goes through the mill, it just breaks down, goes through our processing out in the mill, and comes into these chutes, sits in the piles there, and then we have to open the chutes down here, and the loader pushes it down the hole to go to surface.
My job is to push that finished product to surface, and then from surface they either load it on the rail cars, the boats, or the transport trucks.
I load the salt on the boats, and I load the salt on the rail.
Mainly what we do here is we try to ensure all the product is up to spec, and so we do all the testing on everything that comes from underground, all the samples that are processed in the mill, everything like that. So we make sure everybody knows that it's up to spec and it's good to go out.
And this is the brains of the operation here, right? Take all the telephone calls, we talk to the captains on the boats that come in, we take their load plans, and we send all that information over to the office. And we pretty well look after all the controls on the conveyors, the crushers, the fans, the water pumps underground. Just about everything you can think of comes from here.
It's a great career. It's always changing. There's always new stuff. We got lots of equipment here, lots of great people. You want a challenge, there's a challenge here. It's actually a really great spot to work. Great group of guys. I probably can't say enough.
Well, it's nice being underground. Temperature's always nice. It's not raining on us working on this equipment. It's just a good place to be.
You know, it's a very interesting place to work. There's lots of good jobs, lots of neat jobs, really, when you think about it. This here miner is, as I said, 50 feet long, and you run it with a joystick. You run it with a remote. There's lots of things to do down here, all kinds of jobs in the mill, different areas.
I like working here because it's a new job every day.
The best thing about working here is the atmosphere and the friendships that you make throughout the years here.
My role here at the mine I really love because I get to work with everybody on the mine site, and I get to work closely with the VP.
I couldn't think of a better place to come to work. I have the best view in town, overlooking the beach and the harbor.
So working at the mine here is it's a great opportunity. I think everybody around kind of knows that. It's Goderich and the mine were one of the reasons that my family moved here. So it's great to work here, especially minutes from the site. Amazing commute, an amazing place to work, and great people to work with.
This job here is the best job on the mine site right here. All this modern equipment in here, and I'll tell you, it's great. It's the best thing going right here. And when I started here, everything was push button, and you had mechanical levers to pull. There's none of this electronic equipment here. Nothing. There's nothing here.
I do live in Goderich. I've lived here most of my life. I do know the majority of the people that work here from school. It's like being in school still.
Goderich is awesome. It's got lots of beach areas for everybody to enjoy. Great community, lots of schools in the area, lots of activities for the kids, and pretty family orientated.
And we love it here. Between me working here and us living in Goderich, it's a great commute, it's a wonderful place to work, great people to work with.
So my grandfather started working here in '62, and then my uncle also worked here, and my brother currently is the store supervisor, and my mom also has worked here before too. Yes, it's always been a goal for me to be working here, so I'm very glad to be with Compass Minerals.
All right, so with that, I will open it up for questions. As I touched on, I'm the engineering and capital manager, but I am a bit of a salt nerd, so whatever you may have, I'll probably be able to answer or make something up if I don't know the answer. Yeah, my group kind of focuses on the underground mine design, the underground mine ventilation, ground control, and support of the roof as we mine, as well as some of the production scheduling planning. And then the capital side of things, what's meant by that is the capital spend for the year. So any new equipment purchases, maintenance of the continuous miners, and so on. Of interest, one of those machines costs about $10 million US to bring down into the mine. So significant price, and the mobile conveyor belt behind it is the same, if not more. So a lot of money been spent at Goderich in the last 10 years to really secure the future of the operation for hopefully when that little girl is old enough to work there as well. So last time I did this, it was to a group of elementary kids, and the number one question was, how much money do you make? So I'll just answer it, not enough. But feel free to ask anything.
Anybody has a question, just let me know. And I'll come over and give you the mic. Linda, here you go.
Hi. It might be interesting to people if you told them how you get the equipment down there and what you do with it when it's done.
Absolutely. So I end up giving a lot of the tours underground to the mine, and I have quite a spiel I'll go through, but that's certainly the number one thing I mentioned, because as you walk into the elevator, or the cage as we call it, to go underground, it'll be about a half-moon shape. It takes up half of the circular shaft you go down. It's about 14 feet wide and maybe 8 feet deep. So every bit of equipment that you saw in that photo had to be disassembled small enough to fit down underneath that cage and slung into the mine. We can lift about 34,000 pounds at a time, so any components heavier than that have to be taken apart. The buckets of those large haul trucks would have been cut in half, put underground, and welded back together once down there, and sometimes we have to do that with the frames of equipment as well. So most stuff that goes down in the mine, it's actually kind of a somber thing, but when you see it go down the shaft, it's never going to see the light of day again. We will bury it in an underground mine opening when we're done, because when we're done with it, it's not worth anything. It's lived its useful life. So, good question.
Do you have a question too, here? No?
I need a geological education, I guess. So you're saying the bottom of Lake Huron is all rock that you're getting the salt out of, and then you drill in and make like a cave into this rock?
So the shafts go down about 1,800 feet, and then we're more or less all on one level within the salt seam. So there's no development waste at our mine. A lot of mines have to mine through different rocks to get to ore. We do not have to. It's all what you'd call ore. So we mine those 60 by 60 openings, and we've extended all the way out to 6 kilometers. Above our head, there are other layers of salt. For example, the Evaporator plant mines at about 1,000 feet, and we're at 1,800. But above us is all rock. So about 30 feet we leave in the roof of salt for stability to make sure we don't damage the rocks above. And then above that is about 900 feet of tight rock or dry rock, and then about 900 feet of water-bearing rock, which then brings you to the bottom of Lake Huron. Lake Huron's not a particularly deep lake when compared to, say, Superior or something, so it doesn't get that close to us. The town I'm from in Nova Scotia was a coal mining town. Certainly the whole area was in the Sydney Coal Basin. But those mines go out under the Atlantic Ocean, and at times there might only be 200 feet between the bottom of the ocean and the roof of the mine itself. So I'm much more comfortable here in Goderich than in one of those operations. And I actually visited a mine there last year, and it was a coal mine, and I don't want to be a coal miner in general. I'll stick to salt.
So who actually owns all this underneath the lake?
The people of Ontario. So it is a resource that we have to pay a royalty on to mine every year. We pay a certain price per ton skipped out of the mine as a product.
Great questions. Thanks very much. I have a question. Having born and raised here in Goderich, people always ask, can you get into the mine? Can tourists go there and see it?
No, it's not. As you can imagine, we're an operating business, and even though I mentioned safety is paramount and we strive for zero injuries, it still is a concern to have the general public down there. So a couple years ago, I think 2 years ago, last year we did a family tour day where we do open it up for some of the wives and children of the people in the mine, if they're a certain age, obviously, to go underground. We don't get to go out in the mine workings, but you do get to go down the elevator and see the area, see the equipment. We bring a lot up to that area to look at. So it is possible if you know somebody at the mine. and I don't think the family is that strict. It might not be a direct family. So hopefully we can do that in future years. About 2 years prior to that, we were able to do a family tour day as well. So we took, I think, over 500 people down into the mine those years to see the mine and see what takes place. I always joke that it's good if your husband's complaining about how bad the mine is, you get a chance to see it's not bad. It's actually quite a nice place. It's a little town down there. So
It is a different world down there. I had the opportunity to visit the mine years ago. I became somebody's family, I guess. I don't know how I got there. But anyway, it was amazing. It really is. This doesn't do justice. The photos you see don't do justice to what's down there.
And unfortunately, I speak very nonchalantly about it all because I see it all the time, and my whole career has been in salt. But we do incredible stuff every day. We have impressive machinery. It's a great place. It's incredibly neat. As the capital manager, we get to, 6 months ago, we were planning a conveyor belt project to spend millions of dollars to build new belts in the mine to access new areas. And just last week, we really commissioned those belts. And you get to see it from a whiteboard drawing or a napkin at the bar to fruition and actual construction underground. As part of the donations committee I mentioned, we actually do lately been pushing a lot for donating to events around town where we'll auction off a tour for 3 people. So we did that recently for the White Party dinner in town here, and the tours went for $7,500 each, which was fantastic to see. It's a great cause, but they don't always go for that much. We've done a few for like the local elementary school too that might have been a few $100s, for example. So every now and then, if you go to those charitable events, there is an opportunity to bid on a tour.
Any other questions out here? Yes, sir, please.
Can I ask 2 of them?
Depends on the first one.
Yeah, depends on the first one.
Okay, question number 1. The evaporator plant, if I'm not mistaken, the salt that goes there is 1,200 feet down, and the mine is actually 1,800 feet. Are they 2 different salts?
Yeah. So as I mentioned, the rocks are pretty flat. So they are 2 different salt seams that we mine, and that really ensures that we don't ever have any chance of interacting with each other, because that would obviously be terrible to be mining near some of those caverns that are full of brine. So 2 different layers, and they're not the only 2 layers. There are a few other salt seams within the rock bed. So salt's what you'd call a plastic rock or a soft rock. So it's not brittle like the hard rock mines you'd see in northern Ontario. If you put stress on it, it will move over time, and creep, we call it. The best example I've heard is like a piece of silly putty. It's hard when you put it on the edge of a desk, but if you came back, it'll creep over the edges with time. So salt's like that, and they actually act as a good insulator between us and the water. So any movement or cracking that takes place, it doesn't break the salt, it just kind of bends it and keeps us separated from that water above.
So both salts could do the same job?
Yep. Yeah, I don't know the purity of theirs or anything, but we pick the location that we pick in the seam due to essentially it being pure enough for highway salt. One of the other mines I was at in Nova Scotia, we mine between 89 and 92% salt on a normal basis, whereas here we're generally all above 96% and it all meets highway grades. So we're lucky to have that resource.
Any other questions out here? Number 2. I thought that was 2. Wasn't that 2? You got another one?
The other question is, I think there's a huge standby generator at the top. What kilowatt is that thing?
That's a good question. I think they're dual 1.5 megawatt, but don't quote me on that. So they are significant. They're natural gas fired. They are for emergency. We can run any one of our 3 hoists on them if we have to bring people out of the mine in the event of a disconnect from the grid, for example. The other thing they're used for is peak shaving efforts. So because on, say, the very hot days in Ontario, the grid demand is huge when everybody gets home and turns their AC on and their dishwasher and so on. So on those days, we actually get a warning from the government that it's going to be high demand. If we run our generators and lower our peak draw, it will lower our power bill for the following year, because everything is based on both power consumption as well as peak demand, because that's how much the utility has to be able to give you at any given time.
Thank you, Robert. Any other questions? Oh, yeah, good, yep.
You mentioned one part of your job is about the venting.
Yep.
Can you talk about the air quality in the mine and when that comes out of the mine, the air quality in the town? Because it looks like there's a lot of particles in the mining process.
Yeah, absolutely. So I guess I touched on when we were drill blast, there was a lot more contaminants from the explosives in the big trucks. We don't have that problem anymore, but as you saw in the videos, when the cutting machines cut, they make a lot of dust just through the process. Coal mines will often use water to suppress that dust because coal explodes. Where we don't want water in the product, it leads to not spreading and dissolves the salt and so on. Salt is what you'd call a nuisance particle, or a nuisance dust. So it doesn't have any long-term health effects on the lungs. You'd think it's a mucous membrane, it would absorb salt, and you'd have high blood pressure, which I do, but it's not related, because there are long-term studies showing that there's no ill effect from 40 years of salt mining on breathing the salt dust in. The salt itself is a fairly large particle in the air. So where we're moving it through big 60 by 60 openings, the speed of the air, the velocity is fairly slow, and that particle has a chance to separate out as it travels back. So you will see some water come up at the shaft if you drive down there, just kind of the condensation and water from the shaft's infiltration. That's blowing out on the area. You do see some dust in the area when we're loading boats on dry days and things like that. But it doesn't really carry too far away from the site, I would say. And it's not a black product like you'd see at a coal terminal where it ends up on houses and siding. So yeah, it mostly settles out not too far from the continuous miner, to be honest, by the time it reaches a few thousand feet away.
That's a great question.
Some operators will wear a dust mask out of preference, but it's not something we mandate to employees just because there's no long-term effects of that. And we do conduct a significant amount of studying every year, sample taking of how dusty it is, and work with hygienists on that data.
Great question. Thank you. Anybody else? I want to thank, oh, you have a question back there? Sure. Yeah. Let me run back here. Can you see me, guys? All right. Here we go.
Just wondering on the recall, there's still how many out, and is there a projected last recall of employees?
Yeah, so what this gentleman is touching on, unfortunately, I mentioned we used to run a four-shift, 24/7 schedule, so we ran 2 12-hour shifts every day. Due to the mild winter last year, there were quite a lot of layoffs at the mine. About 22% of the workforce was laid off because we just didn't have demand for the salt and we had to slow our production way down. So with that, we went from a 24/7 schedule to a Monday to Friday, 3 8-hour shifts to reduce production. And since then, we've actually brought, I don't know the number, sir, sorry, but I would say half those employees are either back or start this coming week. So we've brought quite a bit back over the summer months. There are quite a few, unfortunately, gentlemen and ladies still laid off, which we hope for a strong winter to bring them back in the following year. But I can't commit to anything because we just don't know how winter will fall out. But